Okay, so we're going to teach you something, but if we want to solve the 4 period problems in one shot, that's going to be too complicated at this moment. So let's say there is a 1-day problem. Suppose we have only 1 day to make our decision. Okay, so at the beginning we have y1 units on hand, or let's say 5. Okay, suppose we have 5 units on hand. And we need to produce x1 units. Okay, so this is our decision. And then what we need to do is that in that period, we're going to sell D1 units. Let's say 10. Suppose that's the case, and we have C1 as the production cost and H as our ending our cost for inventory. If that's the case, then how much should we produce? Well, basically, what we need to do is to focus on the amount we need. So here, our x1 is our decision variable, okay? We want to find x1 to minimize what? Minimize this. We want to minimize our production cost plus our inventory cost, which is the total cost we need to pay, all right? And here, let's take a look at our inventory cost. Initially, we have y1. Plus x1 is the amount I add into my inventory pool, minus d1, which is the amount I sell. So y1 plus x1 minus d1 is my ending inventory, right? So the whole thing here indeed is our cost. And here the thing is that I have a constraint. What's the constraint? The constraint is that I need to satisfy all the demands. So here, if d1 is greater than y1, like here, we have 10 minus 5, right? So that means I need to produce at least 5 units. So that's exactly D1 minus Y1. But if D1 is less than Y1, let's say D1 is 3. In that's the case, then you don't need to produce anything, okay? So we say X1 must be greater than or equal to D1 minus Y1 plus, okay? So this plus is a notation that is widely used, which means we are taking the maximum of D1 minus Y1 and 0. If the number is positive, then it is the number. Otherwise, it's 0. Okay, so if we have the formulation here, let's take a look at this formulation again. We want to find a value of x1, where the constraint is x1 must be satisfying the demands. And we want to find x1 to minimize the total cost. Okay? And here we denote the optimized objective value as V1 of Y1. Okay, this is very important. So I'm going to box it with the red pen. So what's this? This is a cost function for one period given our initial situation Y1. If we have a 1 period problem and initially we have Y1 units on hand, after we make our optimal decision, the total amount of cost I need to pay is V1 of Y1. Okay, so for this particular problem, the thing is not too difficult. We can easily say, all right, our optimal decision is the following. If I need something, then I'm going to produce that. Otherwise, I don't want to make production because then I can save production cost. And you can also see that if I don't need anything, then I don't want to produce because producing more just giving more ending inventory and more inventory cost to pay. So if I need something, I produce something, otherwise I don't. And given that I have my x1 star as my optimal solution, V1 of Y1 can also be derived for any possible Y1. Okay, so this is our 1-day problem.